Yes.
Site of action and site of secretion can be categorized in some groups, okay? Site of secretion and site of action include endocrine, neurocrine, paracrine, autocrine, okay? First, endocrine. You know endocrine?
Yes.
Mm-hmm.
It's the release of hormones, and and these hormones, they cause effects in the cells to create changes in the body. Oh, okay, wait, you mean endocrine signal. Endocrine, the hormone goes to the blood.
And the keyword is in hormone into the blood, okay?
And go to the target cell.
Okay, remote target cells has effect on remote target cells, but enter the blood and travel in bloodstream. Name endocrine, okay? Neuroendocrine.
The hormone is released from the ends of the neurons, and it causes effects in the other neurons.
Okay. End of neurons, okay, secreted and enter the blood stream and has effect on remote target. Paracrine.
Paracrine, the hormone is released, and it doesn't travel in the blood, but it travels in the cells, like intracellularly to the other cells, but only to cells which are nearby, not to remote cells.
Neighboring cells, okay? Hormones secreted by cells and has effect on neighboring cells of a different type. Neighboring cells, different type. Name paracrine, okay? Autocrine.
The hormone affects either the same cell or from other cells of the same
All
type.
cells and same neighboring cells. All cells and same neighboring cells named autocrine. Okay? Principal endocrine glands. We have some glands, some principal or classic glands include hypophysis, thyroid gland, parathyroid, okay? Adrenal, pancreas, ovaries, and testes. These glands named principal or classic endocrine glands, okay? And these glands produce some hormones. Pituitary gland or hypophysis has two parts, anterior and posterior. Anterior pituitary hormones include TSH, TSH, thyroid stimulating hormone, FSH, follicle stimulating hormone, LH, luteinizing hormone, ACTH, adenocorticotropic hormone, okay? MSH, melanocyte stimulating hormone, it's not important. Growth hormone and
Prolactin.
Posterior pituitary hormones.
Oxytocin and
Oxytocin
antibiotic.
and antibiotic. Okay. Thyroid hormones. T3,
T4, calcium.
and calcium. Okay. Parathyroid hormone.
Parathyroid.
Parathyroid hormone, PTH. Pancreas.
Insulin, glucagon.
Insulin and glucagon. Adrenal medulla, norepinephrine, epinephrine, adrenal cortex,
cortisol, aldosterone, and
adrenal testis,
testosterone.
ovaries,
Progesterone, estrogen.
Okay. These glands, classic glands or principal glands. In addition of it, we have some other features.
What about the middle lobe of pituitary, like melanin, keratin cells?
Melanin?
Yeah.
Okay, I say some things in next few slides. I explain about some of this. Hypothalamus, it's not a gland. Hypothalamus is not a gland, but can produce some neurohormones. Include TRH. You know TRH?
Thyroid.
Thyrotropin releasing hormone. Stimulate TSH, okay? CRH, GnRH, GHRH, okay? Somatostatin, dopamine. Hypothalamus is not a gland, but can produce some neurohormones, okay? It's not a Okay. And about other tissues. You know, we have some tissues can produce hormones, but they are not classical. For example, kidney, stomach, small intestine. You studied about hormones of the stomach. Yes, secreted, CCK. Okay, in kidney, renal, activated vitamin D, erythropoietin, heart, ALD. Okay, in this blood, endocrine blood, only we will discuss about which hormones? Classic glands hormones. Okay, classic glands hormones. About function of hormones. Hormones action is very different and multifactorial, okay? And all body's effects, okay, influenced by hormones. Hormones has effect on metabolism, growth and development, homeostasis. So, for example, water and electrolyte balance, regulation of blood volume, blood pressure, heart rate, body temperature, acid-base balance, maintenance of muscle mass and bone mass, reproduction and behavior. So many of function of body controlled by hormones. Okay. Chemical structure of hormones. Hormone classes. Okay, is two classes. We have two classes of hormones. Derivatives of cholesterol and derivatives of amino acid. Which hormones derive from cholesterol?
Aldosterone, I think.
Steroid hormones.
Yes.
So can we say
Steroid.
steroid
Also
hormones.
testosterone and
Sex hormones and adrenal cortex hormones. Okay, steroid hormones, sex hormones and adrenal cortex hormones. Derivatives of amino acid. Which hormone? Proteins and
polypeptides.
derivatives of amino acid ions. Protein, for example, all pituitary hormones, anterior and posterior, all of them are proteins. Parathyroid, calcitonin, insulin, glucagon. So many of our hormones, okay, is in these items, proteins. And derivatives of amino acid tyrosine, which hormones? Thyroid hormones and
Catecholamine.
Catecholamine. Okay. Catecholamine, for example, epinephrine, norepinephrine, dopamine. Okay. They are catecholamines, and thyroid hormone, you know, T3 and T4. First, peptide hormones. Synthesis of peptide hormones. For all peptide hormones, we have these items: synthesis, packaging, storage, and secretion. For synthesis, first in the nucleus, okay, transcription takes place in the nucleus. Messenger RNA in the ribosome, okay. In the ribosome, peptide produced in the form of pre-hormone. All peptide hormones, okay, synthesized in the form of pre-hormone. After that, enter the ER, endoplasmic reticulum. In ER, pre-isolated, and pro-hormone enter the Golgi apparatus. In Golgi apparatus, pro-hormone converted to hormone, and also packaged inside the vesicles. Okay? Hormone saved inside the vesicles maybe for minutes, weeks, and even months. Okay? When hormone needed, hormone extruded by exocytosis. Mostly exocytosis dependent on calcium. some hormones, exocytosis depend on cyclic AMP. In which hormones? Increasing, usually calcium, when calcium level increase, okay, calcium causes exocytosis, okay? What about some hormones? Calcium inhibits exocytosis. Which hormones? Which hormones?
What?
Which hormone secretion inhibited by calcium? When calcium increase?
Calcitonin.
No.
Parathyroid hormone.
PTH, parathyroid hormone. When calcium level increase exocytosis, but PTH secretion, parathyroid secretion, inhibited by calcium. And the secretion depends on cyclic Steroid hormones. All steroid hormones derive from cholesterol. Okay? Steroid hormones include testosterone, estradiol, progesterone, cortisol, aldosterone. In addition of this, we have steroid-like hormone. And this is activated vitamin D. Activated vitamin D is a hormone produced in the kidney, enter the blood circulation, bloodstream, and has effect on renal target cells. So, it is hormones, but steroid-like hormone. Steroid because derived from cholesterol, but steroid-like because you see here, in all steroid hormones, there is for brain, okay? But here, sin UV break down, okay, hearing, so they steroid-like hormone. Activated vitamin D is steroid-like hormone. Biosynthesis of steroid hormone. Steroid hormone synthesized in which organelle of cells? Endoplasmic, okay. Smooth endoplasmic reticulum. SER. Okay. In addition, which organelle involved? Mitochondria. All steroid hormones derive from cholesterol. Cholesterol comes from outside the cells, mainly outside the cell in the form of LDL and HDL. Okay, come inside the cell, and 20% synthesized from acetate inside the cells. Cholesterol, you know, cholesterol is lipid soluble and easily diffuse in the cell membrane. So, saved in the form of cholesterol ester. Cholesterol ester saved in lipid droplet. When these cells activated by a stimulator, for example, ACTH for adrenal cortex, FSH, ALH for ovaries and testes. Okay? These hormones bind to the receptor on these cells, initiate signaling pathway and increase cyclic AMP, and cholesterol ester converted to cholesterol. Cholesterol diffuse in the mitochondrial membrane. Inside the membrane, inside the mitochondria, cholesterol converted to pregnenolone. Conversion of cholesterol to pregnenolone is the first step and limiting step. First step and limiting step for steroid synthesis. Okay? Pregnenolone enter the SER. Rest steps of hormone synthesis take place inside SER. In gonads, maybe ovaries and testes, steroid hormones, sex steroid hormones, produced inside SER. After production, they are lipid soluble, diffuse, okay, of SER membrane, cell membrane, and go out of the cells. About adrenal cortex hormones, aldosterone and cortisol, final step final step of hormone synthesis takes place inside the mitochondria. Okay? After production of the and cortisol, okay, diffuse mitochondrial membrane, cell membrane, and go out of the cell. So steroid hormones are usually synthesized from cholesterol and are not stored. Peptide hormone, after production, saved inside the cells, maybe for weeks or months, but about steroid hormone not stored. After production, steroid hormones are lipid soluble, so easily can pass the cell membrane and not stop. About hormone derives from thyroxine. Thyroid hormone from 2 tyrosine and catecholamine 1 tyrosine. Dopamine, noradrenaline or norepinephrine, and adrenaline or norepinephrine. About catecholamines, as you see here, tyrosine converted to dopamine, dopamine to norepinephrine, and norepinephrine methylated and converted to epinephrine. In sympathetic neurons, secretes norepinephrine, but in adrenal medulla, epinephrine. Epinephrine 4 times more than norepinephrine. Why? In sympathetic, okay, norepinephrine secreted, but in adrenal medulla, instead of norepinephrine, epinephrine secreted. Epinephrine levels or epinephrine amounts 4 times more than norepinephrine because of these enzymes, methyltransferase. Norepinephrine methylated to epinephrine. These enzymes are stimulated by cortisol. Cortisol from adrenal cortex, okay? Go to adrenal medulla, stimulated these enzymes, and norepinephrine converted to epinephrine. Okay, onset of hormone secretion and duration of hormone action are very different for different hormones. For example, for catecholamines or norepinephrine, okay, secreted within seconds and develop full action within minutes and finish. About thyroid hormone, about GH. For full action, require maybe few months and weeks and months. So, onset of hormone secretion and duration of action different for different hormones. Okay? Some of them is very short and some of them very long. Okay? About hormone concentration, also hormone concentration is low, but for different hormones also it's different from picogram per deciliter to microgram. Picogram to microgram, 1 million times different hormone concentration, okay? And control of hormone secretion. Hormone secretion controlled by oral, chronotropic, and feedback. For some hormones, neural control is important. For some hormones, for example, for insulin, for glucagon. Most of hormones not controlled by neural system, by nervous system. About chronotropic control. You know chronotropic control? For some hormones, sleep-wake cycle is very important. Darkness, lighting cycle is very important. Season is very important. So, this is the chronotropic control. Chronotropic control includes circadian rhythm, rhythm based on 24 maximal 4 to 8 a.m. Is circadian rhythm. In addition, we have infradian rhythm. Infradian rhythm longer than 24 hours. For example, 28-day cycle for 6 hormones in women. Infradian rhythm. And ultradian rhythm, shorter than 24 hours. All hormones secretion fluctuate, and secretion of hormone is pulsating. Okay. Here you see infradian rhythm for LH, FSH, estradiol, and progesterone in women. Here you see circadian rhythm for GH. As you see here, GH, growth hormone, okay? 1 to 2 hours after beginning of sleep, 1 to 2 hours after beginning of sleep, there is peak of GH. For ACTH and cortisol, 4 to 8 a.m. there is peak of these hormones. And for melatonin, GH and ACTH, cortisol, depend on sleep-wake cycle. What about melatonin?
24 hours.
Darkness lighting cycle. Okay? And in darkness, increase melatonin secretion. In hypothalamus, there is suprachiasmatic nucleus. In hypothalamus, there is suprachiasmatic nucleus. This is circadian clock. As you see here, sleep-wake cycle, this nucleus receives some information from sleep-wake, okay? And from eyes, from pineal glands, melatonin produced by pineal glands. So, outgoing message from this nucleus go to endocrine system, metabolic system, and behavior. So, endocrine or hormone secretion influenced by some circadian rhythm. And about feedback, you know feedback, okay?
Yeah.
Yes.
We have
Okay.
negative
and
positive feedback. Mostly
Negative.
negative feedback. Okay, here you see anterior pituitary gland produce TSH, thyroid stimulating hormone. TSH activates thyroid gland to produce thyroid hormone. Thyroid hormone, as a hormone too, has negative feedback on gland 1. This is negative feedback. Negative feedback prevents over-secretion of hormones. Maybe it's better we say prevents overactivity of target cells. Okay, negative feedback prevents over-secretion of hormone or overactivity of target cells. But in addition of negative feedback, we have positive feedback. You know positive feedback? Oxytocin. At the end of gestation, oxytocin causes baby delivery because of positive feedback. And also for ovulations, estrogen. Estrogen in low dose and high dose. A low physiological dose and a high pharmacological dose of estrogen has negative feedback, but high physiological level of estrogen 3 days before ovulations has positive feedback. So estrogen increases LH level, and LH causes ovulation. So, and okay. or positive feedback causes by product. In previous slides, we have hormones. Hormone 2 has negative feedback, but here you see product. For example, calcium. Okay, PTH, parathyroid hormone, has effect on bone and increased calcium level. Calcium as a product has negative feedback. Okay? And in hypothalamus, hypophysis, target gland, we have long loop, short loop, and ultra short loop feedback. For example, thyroid hormone. Thyroid hormone produced by thyroid gland has negative feedback on anterior pituitary and hypothalamus, and named long loop feedback. TSH from hypophysis, anterior pituitary, has negative feedback on hypothalamus and named short loop feedback. And TRH from hypothalamus has also negative feedback on hypothalamus and named ultra short loop feedback. Okay? Transport of hormones in the blood. We have two kinds of hormones, water soluble and liquid soluble. Which hormones are water soluble?
All the hormones except the lipid-based, protein-based ones.
Protein and catecholamines. Protein hormones and catecholamines, they are water soluble. Lipid soluble?
Are the
Steroids.
steroid hormones.
Hormones and
Sex
thyroid
hormones.
Steroid hormones and thyroid hormones, they are lipid soluble. For water soluble, we don't need transport protein. For water soluble, we don't need transport protein. Okay? They enter the blood circulation, blood stream, and travel and reach to remote targets. What about lipid soluble?
They need
For what
to
you
be
need transport protein?
because they cannot be dissolved in water, so they can't be transported in blood.
They have some amounts of them are free, not bound to protein.
But they can't cross, I think, cell membrane and go into the.
They don't have receptors.
No. Lipid soluble, such as
Steroid.
thyroid hormone and steroid hormone, when secreted in the bloodstream, they are lipid soluble. Easily and immediately enter the around cells and could not travel in the blood system. Easily and immediately, okay, absorb or enter the neighboring cells, around cells. They are lipid soluble and easily go inside the cells and could not travel in the blood system and don't reach to remote target cells. Because of it, they have transport protein. Okay? And for these hormones, some percent of them are free. And free of hormone has biologic effects. So biologic effects is due to free hormones. Free hormones, okay? Steroid hormone, thyroid hormone, bind to transport protein. But some percent of them are free. And free hormone has biologic effects. Free hormone can go to inside the cell, has effects, okay? Metabolized, has negative feedback. Only free hormones has biologic effects. Transport protein. Non-specific, specific. Non-specific, for example, albumin. Albumin binds to many hormones. And specific, globulin. For example, TBG. TBG, thyroxine binding, only bind to thyroxine. SHBG bind to sex hormone, CBG bind to cortisol, and this is specific. Clearance of hormone. Hormone, how? Clear. from the placenta?
So one of them, it can be digested. I think acetylcholine is digested,
Metabolized.
metabolized, and also it could be excreted in urine or in
Feces, okay, bile and
Yes. And also goes into the tissue, like dissipates in the tissues.
Okay. That's true. So bind with tissue, metabolic destruction by the tissue, excretion by the liver into the bile, excretion by the kidney into the urine. Okay? So it's better I say about excretion in the urinary. Okay? Intact hormones may be filtrated in the glomeruli, okay, and excreted in the urine. But many of hormones, most part of hormones, first metabolized in the kidney or other tissue, okay? After metabolized for into the blood circulation and excreted in the urine. So in the urine, you have two forms of hormone, intact and metabolized form. Mainly metabolized form excreted in the urine. And here you see formula of metabolic clearance rate. Metabolic clearance rate. Removed hormone, nanogram per minute, per concentration of hormone, nanogram per milliliter. And so here you see cleared hormone from plasma, milliliter of plasma, cleared of hormone per minute. So definition of MCR is volume of plasma cleared of hormone per unit of time, per unit of time. So metabolic clearance rate is volume of plasma cleared of hormone per unit of time. Target cell activation depends on hormone secreted, enter the blood circulation, travel to the blood, and reach to target cells. And target cell activation depends on concentration of hormone, blood level of hormones, number of receptors, and affinity of receptor to hormones. Regulation of number and sensitivity of receptors. Number and sensitivity of receptors change day to day, minutes to minutes. Also, number and sensitivity. Depend on condition, number and sensitivity can change. We have upregulation and downregulation. You know upregulation and downregulation?
Receptors in response to the hormone. It's written there. The hormones, the receptors in response to the hormone increase or decrease.
Oh, okay.
Upregulation is basically when the cell becomes more responsive to the hormone, either it becomes more has more receptors, or it becomes more sensitive. So less hormone makes that makes the same effect. Downregulation is the opposite. The cell becomes less receptive, or less sensitive to these hormones.
Okay. Mostly we have
I think upregulation.
downregulation.
Oh.
Mostly we have downregulation. All, approximately all hormones, except some hormones. When hormone increase, number of receptor decrease. Hormone increase, number of receptor decrease. Try to remain hormone effects in normal level. Hormone increase, receptor decrease. Try to, okay. So, downregulation happens for something. Here you see internalization. After hormone bind to receptor, here we have internalizations, okay? Hormone receptor complex internalized inside the cells, and receptor reside to the cell. Here, in some other hormones, after internalization, lysosomal enzymes, okay, destroy the receptor and hormone. So receptor destroy. After that, receptor have to produce and go to cell membrane. So when hormone level increase, more receptors bind to hormones, internalize and destroy. And we have time for new production of receptors and go to cell membrane. So we have downregulation. Maybe after binding hormone to receptor inhibited by some signaling. Maybe signaling pathway inhibited. And also, because of signaling pathway, some inhibitory protein produced, and these proteins inhibit signaling pathway. And finally, some hormones decrease its own production. Hormone have effect on cell, okay, on target cell, and decrease own production. Okay, so when hormone increase, number of receptors
Decrease.
and we say down regulation because of these items I said. Location of hormone receptor. Hormone receptor located cell membrane,
Cytoplasm, nucleus.
Which hormones receptors located on cell membrane?
Protein-based amino acid.
Water-soluble hormones.
Yes.
Water-soluble hormones. Proteins and catecholamines. Which hormone inside the cells?
Lipid.
Steroid and thyroid. They are lipid soluble, easily pass the cell membrane, and their receptor located in cytoplasm or nucleus. First, steroid hormones receptors. Steroid hormones receptors.
The cell membrane and water soluble.
First, steroid hormone receptors located in cytoplasm. Steroid hormone receptors located in cytoplasm. Hormone bind to its receptors. Receptor complex, hormone receptor complex, okay, past the nucleus membrane, okay. In the nucleus, two hormone receptors, hormone receptor complex, two of these dimerize to each other, and bind to HRE, hormone response element of DNA. Here you see DNA. In DNA, we have hormone response element close to promoter of gene. Close to promoter of gene, there is HRE, hormone response element. So, receptor bind here and change transcription, maybe increase or decrease transcription, and increase or decrease messenger RNA, and finally increase or decrease protein synthesis, okay? And leads to response. About thyroid hormones, thyroid hormone receptor located in the nucleus, steroid hormone in the cytoplasm, thyroid hormone receptor located in the nucleus and bind to TRE, thyroid response element of gene. So, receptor bind to HRE or TRE, tyrosine response element of gene. Okay? But repressed by co-repressor. Co-repressor repress this receptor. When thyroid hormone enter the nucleus, bind to receptor, and co-repressor dissociate, and co-activate or recruit, and activate the gene transcription, activate gene transcription and increase messenger RNA. So, steroid hormones, thyroid hormone, and also a vitamin D receptor located in the nucleus. Thyroid hormone and vitamin D, activated vitamin D receptors in the nucleus, steroid hormones in the cytoplasm. So, all these receptors similar. These receptors similar. They have ligand binding domain or hormone binding domain and DNA domain. And DNA domain bind to DNA and increase or decrease transcription, increase or decrease messenger RNA, and also protein synthesis. For example, glucocorticoid or cortisol suppress transcription of inflammatory factor. You know, cortisol is a
Cortisol?
Cortisol has a anti-inflammation effect.
Yes.
Decrease inflammatory protein. So some of these hormones may be increase or decrease protein synthesis. Cortisol decrease or suppress inflammatory factor production. Okay? This is example. Okay, cell membrane hormone receptor. Inside steroid hormones receptors located in cytosol, thyroid hormone and activated vitamin D in the nucleus, and others, peptide hormones and catecholamines receptors located in
Cell
cell
membrane.
membrane. Okay? Now, I will discuss about cell membrane hormone receptors. There is three kinds of cell membrane receptors. Ligand-gated ion channel, ligand-gated ion channel, G protein coupled receptor, and enzyme-linked receptors. You know about ligand-gated ion channels. For example, which you study about this item, acetylcholine. Acetylcholine binds to receptors, to its receptors, and open
Gates, ion gates.
ion gates.
Yes.
Okay. As far as I know, by now we have no classic hormone act via this item. Okay? We have no. So all peptide hormones and catecholamines act via these two, B and C. G protein coupled receptors and enzyme receptors. Okay? You know G protein coupled receptors?
Yes. I know that they bind to the G protein, and then the complex, hormone G protein, it binds to the receptor, and that's how the hormone, reaches the initiates. Yes.
Okay. For G protein coupled receptors, all these receptors have 7 transmembrane segments. 7 transmembrane segments, loop in and loop out. Okay. Inside the cells, there is G protein. G protein is trimer. After binding hormone to receptors, G protein connect to receptors and initiate signaling pathway. Okay, in next slides, I will discuss about this item. And enzyme-linked receptors, we have some kinds of enzyme-linked receptors, but 2 kinds of it is very important for us, for endocrine hormone actions. Only 2 enzyme-linked receptors. We have some kinds of enzyme-linked receptors. First, receptor has one segment, one membrane, segment, and inside the receptors has tyrosine kinase activity, but is inactive form. When hormone bind to receptor, this domain inside the cells catalytic domain or tyrosine kinase domain is inactive, when hormone binds to receptor, this domain activated. Okay? But another one, receptor has no enzyme activity. Receptor has no enzyme activity. After binding hormone to its receptors, accessory protein has enzyme activity, binds to inside the receptors. So, we say, first one, tyrosine kinase receptors. Second, tyrosine kinase associated receptors. You know, for enzyme-linked receptors, we have some kinds of receptors. Only two kinds is important. Okay? Two kinds is important. First, tyrosine kinase receptors. Second, tyrosine kinase associated receptors. What's the difference between two? Okay? First one, receptor has enzyme activity inside the cells. Okay? Receptor has three parts. Outside, okay, in the membrane, and inside domain. Okay? Inside domain of receptor has enzyme activity, tyrosine kinase activity. When hormone binds to its receptor, this domain activated.
There's no pointer when you're pointing with the mouse.
Oh,
There's no
you-
pointer.
Oh, oh,
لا هي خلاص هتتحرك.
oh, what happened?
I think if you right click, you can get the option for the pointer.
See here. Okay, two kind of receptors, two enzyme-linked receptors. Okay, important for us. One kind, first one is tyrosine kinase receptor, and this tyrosine kinase associated receptor. First one, for example, insulin receptor. This is insulin receptor. When insulin binds to its receptor, inside domain activated. Inside domain has enzyme activity, has tyrosine kinase activity. Insulin binds to its receptor, and this domain activated, so this domain is tyrosine kinase activated. And we name tyrosine kinase receptors. And this one, GH receptor. GH receptor, okay, this receptor acted by this receptor. Here you see receptors, GH receptors, outside domain, inside domain, but inside domain has no enzyme activity. When GH binds to its receptor, accessory protein, other protein, with enzyme activity, with tyrosine kinase activity, bind inside the receptors. And we name tyrosine kinase associated receptors. So we have two enzyme receptors. So, this is insulin receptors, tyrosine kinase receptors. Insulin binds to receptors. Insulin binds to its receptors. Tyrosine kinase activated, and You know tyrosine kinase? Tyrosine kinase. Tyrosine kinase enzymes phosphorylate
Tyrosine.
tyrosine amino acid. Tyrosine kinase phosphorylate tyrosine amino acids. So, tyrosine kinase activated by insulin and phosphorylate succinate and initiate signaling pathway. Initiate signaling pathway for produce effects of insulin. About tyrosine kinase associated receptors, also named cytokine receptors, because many of cytokines act via these receptors. Many of cytokines act via this receptor, and these receptor named cytokine receptors. GH, growth hormone, and prolactin act via these receptors. Growth hormone and prolactin. Hormone bind to its receptors. Okay. JAK is a tyrosine kinase protein bind to inside the cell, inside the receptors. JAK is a tyrosine kinase. What happened? JAK is tyrosine kinase. Phosphorylate tyrosine inside the receptors and also each other. Okay? So we have here phosphotyrosine. STAT, signal transducer and activator of transcription. STAT is a transcription factor, but is inactive. STAT is an inactive form. When JAK binds to its receptor, phosphorylate receptors and JAK cross back to each other. STAT recruit to phosphotyrosine. When phosphotyrosine formed, okay, attract STAT. STAT love phosphotyrosine and bind to phosphotyrosine. When STAT bind to phosphotyrosine, JAK is an enzyme, is a tyrosine kinase enzyme. So phosphorylate STAT, phosphorylate tyrosine on STAT. So STAT has phosphotyrosine, STAT bind to each other and dissociate from receptors and bind to each other, and is an active form of STAT. Is a transcription factor, active form, enter the nucleus and activate transcription, lead to response. So, and we say this pathway, JAK-STAT pathway. You've heard JAK-STAT pathway? No. Okay. So, we have tyrosine kinase and tyrosine kinase associated receptors. Insulin act via tyrosine kinase receptor, growth hormone and prolactin act via tyrosine kinase associated receptors. Four hormones act via tyrosine kinase signaling. Two of them tyrosine kinase receptor, two of them tyrosine kinase associated receptor. Growth hormone and prolactin. Cytokine receptor or tyrosine kinase associated receptor, insulin, and insulin-like growth factor 1 act via tyrosine kinase receptor. So, only remain G protein coupled receptors, G protein CAP receptors. So, our receptor located in the nucleus for thyroid hormone, activated vitamin D, in the cytosol for steroid hormones, peptide hormones, receptors
Cell brain,
on the
cell
cell
membrane.
membrane. Cell membrane, we have two kinds of receptors, G protein coupled receptors
And
and
thyroid.
enzyme linked receptors. For enzyme linked receptors, two kinds of
Enzyme.
okay, important. For
Tyrosine.
GH and prolactin and insulin and IGF-1. Okay. Other peptides hormone act via G protein coupled receptor. G protein coupled receptor. You know about G protein coupled receptors, okay? These receptors have 7 transmembrane segments. Okay? Loop out, loop in. G protein has 3, okay, monomer. Alpha, beta, gamma, okay? Alpha, beta, gamma. Alpha bind to GDP, and this G protein bind inside the cells, inside the cell membrane. After binding hormone to receptor, conformation of receptors change, and G protein bind to inside the receptors. GDP dissociate, and GTP bind to alpha. Alpha GTP dissociate from beta gamma and can stimulate many effectors and initiate signaling pathway. Here you see receptors, trimer G protein, alpha bind to GDP, when hormone bind to its receptor, G protein bind to inside the receptors, GDP dissociate, GTP bind, alpha GTP activates some effectors and initiates signaling pathway, but alpha is GTPase. What's mean?
It dissociates the GDP.
Alpha is GTPase immediately, within milliseconds, GTP hydrolyzed to GDP. GTP hydrolyzed to GDP. Alpha GDP bind to beta gamma and recycle to alpha. So, hormone binds to receptors. Receptor bind to G protein. GTP dissociate and GTP binds. And alpha GTP activates some enzymes, some effectors, and initiates signaling pathway. We have some kinds of G protein. Which of them important for hormone action? We have some kinds of G protein. GS, GI, and GQ. Only 3 of them. We have kinds of G protein. Only 3 of them important for hormone action. GS stimulate adenine cycles, okay? GI inhibit adenine cycles, and GQ activates phospholipase C. So only these G protein are important. First GS. GS stimulate or activate, GS activates adenine cycles. How converts ATP to cyclic AMP. Cyclic is a second receptor. Cyclic AMP activates protein kinase A. Protein kinase A is activated by cyclic AMP. This is active form of protein kinase. So ATP converts to cyclic AMP. Cyclic AMP activates protein kinase A. Active protein kinase A to active protein kinase A. Protein kinase.
It's
Phosphorylate
protein.
proteins. Protein kinase. Tyrosine kinase. Phosphorylate tyrosine. Protein kinase. Phosphorylate proteins. Okay. So protein kinase A. Phosphorylate protein. Phosphorylate protein. And phosphoprotein leads to cell response. In addition, we have GI. GI inhibits adenine cycles. Okay? Okay? And two inhibitory actions. GI inhibit adenine cycles and has inhibitory action. Which hormones act via GS? Many of hormones. Many of hormones act via GS. You see here CRH, GHRH, FSH, LH, DSH, SCDH, and others. Okay? Many of hormones act via GS. About GI, only two inhibitory hormones act via GI. Dopamine and somatostatin. Dopamine and somatostatin, they are inhibitory hormones. Inhibitory hormones act via GI. Okay? Here you see GQ. GQ activate phospholipase C. Phospholipase C break down phospholipid. Phospholipid is PIP2. Okay, here you see phospholipid, PIP2. Phospholipase C break down it. Okay, and lead to DAG and IP3. So IP3 and DAG. IP3 inside the cells bind to its receptor and increase calcium level inside the cells. And DAG activates protein kinase C. Protein kinase phosphorylate protein and lead to response. Okay. GQ activate phospholipase C break down phospholipid, PIP2 converted to IP3 and DAG. IP3 increase calcium level and DAG activate protein kinase C. Which hormone acts via GQ?
Phospholipase.
GnRH, GHRH, TRH, ADH.
All of them is neurohormones of hypothalamus. You know neurohormones of hypothalamus. In next session, I will discuss about hypothalamic neurohormones. Hypothalamic neurohormones, GnRH, GHRH, TRH, CRH, isn't here, CRH, ADH, ADH and oxytocin. Also dopamine and somatostatin. We know about dopamine and somatostatin. Dopamine and somatostatin act via
Inhibitory
GI.
G protein. Inhibitory.
Only CRH act via GS. All of them act via G. So it's better for memorizing. All hypothalamic neurohormones act via GQ. except CRH,
and
act via GS.
and
Dopamine and somatostatin we know act via GI. Dopamine and somatostatin is inhibitory hormone, act via GI, CRH, GS, and all neurohormones act via GQ. And one thing, ADH has two receptors. ADH has two receptors, V1 and V2. V1
in
GQ, V2 GS. Only two exceptions. Only two exceptions. Dopamine and somatostatin we know GI. Only two exceptions. CRH and ADH-V2 via GS, others GQ. So all hormones, thyroid hormone and vitamin D act via no. Thyroid hormone and activated vitamin D. All
In the
hormones
nucleus?
we review all hormones receptors. We want to review thyroid hormone and activated vitamin D,
The nucleus?
nucleus. Vitamin D and activated vitamin D and thyroid hormone, nucleus.
Nucleus.
Steroid hormones,
Cell membrane.
cytoplasm.
Cell membrane.
Peptide hormones,
Cell membrane.
cell membrane. From peptide hormones, growth hormone and prolactin, cytokine receptors. Insulin and insulin-like growth factor,
Associated.
thyroid kinase. All other G protein, GI,
somatostatin,
somatostatin and dopamine,
Dopamine.
GQ,
Hypothalamus.
hypothalamic neurohormones except CRH and ADH-V2, others GS, holotropin, GS, parathyroid hormone, GS, FSH, GS, LH, GS, others, GS. Okay, it's better to memorize. Okay?
Yes.
Act as a second messenger, you know about calcium.
Yes.
And final things is amplification. For cell membrane receptors, we have amplifications. Cascade, okay, cascade. Here we have first messenger. Hormone is a first messenger. Produce second messenger, third messenger, fourth messenger. Because of it, we have amplification. Here you see epinephrine effects. One molecule of epinephrine, okay, activates 100 molecules of G protein, and also G protein increase activate adenine cycles, increase cyclic AMP, protein kinase A, and finally 1 billion molecules dissociate from glycogen. Okay, we have here amplification because of second messenger, third messenger,
Yes.
fourth messenger. For intracellular receptor, we have no amplification inside cell for steroid hormone receptors and thyroid hormone receptors. Okay, one hormone bind to one receptors and complex of hormone receptor connect to DNA, bind to DNA, and so there is no amplification for steroid hormones, thyroid hormones, or inside the receptors. Okay, we have no amplification. Only for cell membrane receptor, because of second messenger, third messenger, fourth messenger, we have amplification. A small amount of hormones can induce major effects, okay? So here we have amplification. About hormone measurement, you don't need to study about your reference for exam is Guyton. Okay, Guyton is good for exam. Chapter 75. Here, today's lecture is 75. For next session, 76. 76, hypophysis, we have 2 sections for 76 chapter. And finally, last session, 80. Only 3 chapters, 75, 76, and 80. Okay? And these 3 chapters, enough for exam, okay? But chapter 75, end of chapter 75, about hormone measurement. You don't need to study it for exam. Oh, okay.
Is the media enough for final exam?
Okay. Only book, vitamins, book, and that's enough for exam.
No, your slide. Your slide.
My slides is more than items. Okay, you study about my slides and book. Book is very good. I think book is enough. I discuss many things about, especially in next week and next 2 weeks into session 2 and session 3. I will discuss about hypophysis and my slides and content of my slides is more than book. Okay, and it's difficult for me. So I think 3 weeks, 3 chapters is enough. 3 chapters are enough for exam. And chapter 75, today's lecture is about chapter 75. And end of this chapter is measurement of hormone. It's not for any student, for medical students, or lab students. Don't study this.
What's the topic of 75 that is not included in exam?
Measurement of hormones, not needed.
Okay.
End of chapter, measurement of hormone. You don't study this.
Any last time?
Okay, thanks very much.
Very much. Next.
Doctor,